everyone. So let's start for the mechanics of deformable bodies. But first, let me give you an overview of what we will be tackling on the mechanics of deformable bodies. Okay, the first one is all about the stresses. Okay, so technically yung stresses, that is the result of the applied force kung ano man yung meron tayo sa body. For example, itinulak mo yung katabi mo, na stress yung katabi mo. Okay? So, we will deal with the different types of stresses. Okay? Kung paano siya nag-a-act dun sa ating body. Okay? So, kailangan mahalaga dito yung knowledge nyo sa statics. Okay? So, after the stresses, ang kailangan lang natin doon is the statics itself. Okay? Pero pag pumunta tayo sa chapter 2, which is called the strain, which I will be discussing soon, ko-consider na natin yung deformation niya. Okay? Kukumputin ko sa inyo, let's say, yung ball pen, hinila ko, okay? Gaano kalaki yung i-move niya or i-elongate niya, okay? In millimeters or in inches. So, iyon yung kukumputin natin sa strain, ano? So, may kinalaman siya syempre sa mga forces at sa laki ng member. I-incorporate na rin natin yung material. Okay? So, i-discuss natin yung ating stress and strain diagram on this part. Okay? And then, the next topic, which is the chapter 3, we will deal with the torsion. Yung torsion, okay, yun naman yung pagpihit, ano? Kumbaga, yung pihit. Pag pinihit natin yung isang bagay, sa nyo, napaka-applicable, no? Sa mechanical engineering, napaka-applicable kasi most of the machines, okay, yung mga, ano tawag natin doon, yung mga axle natin na may mga gear, okay, napakalalaki ng torsion doon, ano? Okay, so, is sa mahalagang application yun. So, on the torsion. Okay? And then, of course, as part, so we will be having the shear and then the moment diagram, which is on the chapter 4. Okay? And then, pag inabot pa natin, we will deal on the chapter 5, which is stresses in beams. Okay? Pero, I guess that would be an optional para sa mga mechanical engineering. Okay? So, basically, those are the 5 topics that we are going to deal. Okay? So, first, anuhin muna natin yung ating stress. Okay? So, actually, stress, sabi ko nga, it is the result of the external force. No? What is external force? Okay? Okay. Ina natin, the difference between external force and then internal force. Okay. Example, meron akong isang bakal, no? O isang bar. Okay? So, assuming I have here a bar. Okay? Na meron akong length na ganyan. Okay? Tapos, hihilahin ko to dito. Okay? Hihilahin ko at certain force P. Okay? Itong P na to, ito yung paghila mo. Ang tawag dito, this is called the external force. External force. Okay? Pero di ba pag ginihila mo yung bakal, hindi naman siya kagad nababalik. Hindi naman siya kagad nade-deform. Okay, kahit nga hilahin mo ng malakas yan, hindi yung made-deform eh. Okay? It is because may nagre-resist doon sa force na yon. Okay? So, yung nagre-resist dito sa external force is actually what you call the internal force. Siya yung nagre-resist. Nasaan siya dyan? Makikita mo lang yung mga internal force kapag nag-cut ka ng section. Halimbawa, pinutol ko yung bakal dito. Okay, pinutol ko yung bakal dyan. Okay, pag pinutol ko yung bakal dyan, dyan may expose yung aking external force. So, meron ako ditong load, which is load P, the external force. And dahil pinutol ko to, okay, yung bakal doon, so magkakaroon yun ng tinatawag nating internal force. Okay, internal force. Okay? So, dito sa mechanics of deformable bodies, we are always after for this internal forces. Hindi natin kailangan si external forces, pero we need to have the external forces para makuha natin yung internal force. Okay? So, kumbaga, ang kailangan natin at the point of the section, makuha natin siya. Dito sa problem natin, nakita natin na same lang yung value. So, we have the P as external force and we have the external force P. Bakit? Kasi dapat, of course, it should be an equilibrium. Kung magsasummation ako ng forces horizontal, kung may humihila ako pa kanan na value of P, para ma-stabilize siya, yung internal force ang magre-resist sa kanya at hihilahin din yon by external force P. So, ito yung mahalaga dun sa atin. Internal force. Okay? Now, itong internal force natin, kadalasan for simplification, tumatama. Okay, ang assumption natin, no, as of now, tumatama siya lagi sa centroidal. Okay, ano po yung centroid? Balik tayo sa statics, di ba? Center of gravity, center of mass, or centroid itself. Okay, so let's say meron kang bilog. Okay, I will be having here, what you call this one? Sample. Example, I have here a certain box. O, sabihin na natin yung column. Yan. And then, meron ako ditong force P na ina-apply. Okay, assuming the force P. Ang assumption palagi, okay, lagi siyang tumatama dun sa aking centroidal. Okay, oops. Ayan, pangit ng pagkakadrawing. Yan na natin, ayusin natin. Okay, unahin ko yung centroid, no? So, kadalasan centroid yung tinuro sa atin sa physics, no? Yung Plumb-Bob method. Okay? Kung natatandaan nyo yun. So, we will be having here, ayun, yung nandun, dun tumatama yung ating centroid. Okay? Ngayon, tumatama yung centroid natin dito sa area na to. Alright? Yan. So, dun siya tumatama. Kapag yung isang force, although that is acting on the centroid, pero tumatama siya dun sa pinaka-area mo, iyon yung nagpo-produce sa atin ng tinatawag nating stress. Okay? So, since external pa lang siya, okay, nasaan dyan yung aking parang internal forces? So, I will try to cut this section. Okay? Try kong i-cut yun sa section na yun. Okay? So, ilagay ko dito. So, I will be having here this one. Okay. And then, itong P na to, okay, dahil nag-a-act siya sa centroid, okay, so I will be having here point P. Okay. Ngayon, yung internal force ko, which is on this part, okay, lagyan ko doon, dito sa area na to. Kasi pinutol ko siya, no? So, nung pinutol ko siya, na-expose yung area na to. So, this area, na-expose yan. Nagkaroon tayo ngayon ng tinatawag nating uniform. Kasi syempre, dapat yung force P ganun din, no? Pero uniform yan. Okay, parang nakaganon. Black din siya. Okay? Na nakapatong. Kumbaga yung force niya, kung titingnan natin lang iyong part lang na yon. Okay, para siyang box, may uniform na box. Okay. Ayan, parang ganyan. Pero pababa lahat ng forces niya. Okay? So, parang, kung paangat naman siya, okay, example, we will be having here this one. Marami siyang force na ganun. Punong-puno yung area mo, no? So, punong-puno yung area mo ng mga forces. Okay? And then, yung magnitude na yon, okay, that is syempre yung force P natin and then over the total area. Okay, so you will be having here your area. Let's say you have here B and then B. So you will be having here the A. So that is equal to P. Ang area natin is B times B. So you will be having B squared. Okay? Iyon yung pinaka-uniform na yan. So ang tawag natin doon, iyon na yung ating stress. So we will be having here the force P all over the cross-sectional area. So ito yung una nating definition ng stress. Okay? So, ang tawag natin dito is axial stress. Okay? So, we will call it as axial stress. Okay? So, later on, makaka-encounter tayo ng different stresses. Okay? So, for now, ang tawag natin is axial stress. Yung axial stress, yun yung stress na napoproduce kapag yung force ay perpendicular doon sa area. So, perpendicular. I guess hindi na to. Hindi pala to kita. So that is called the axial stress. Ayun, axial stress. Okay, so huwag ko na dyan ilagay. So this is one is called perpendicular, no? So dapat yan force P is perpendicular perpendicular to area. Okay? So, that is an axial stress. Kapag ganyan, ano? Okay. Ngayon, that is just a simplification. Okay? May mga nangyayari po kasi talaga na sabihin na natin non-uniform. Ito yung reality na nangyayari, no? So, it is according to the Saint Venant. So, sabi niya, kapag daw yung force P mo, okay, for example, I have here the force P. Okay? So, force P. Tapos, yung cutting section, yung stress, yung cutting section ko, itong length na to, malapit dun sa end na nilalagyan ng force. Okay? So, let's say that's around 0.5 of B, yung dimension. Okay? Let's say, ang B natin is 500 mm. So, let's say, malapit na malapit siya. Ito daw, hindi uniform yung stress. No? Gawin ko lang two-dimensional. Okay? So, parang ganito lang. Ito yung force P ko. Tapos, ito yung 0.5 of B. Okay? Again, ito yung B. Okay? Yung dimension yung B. Tapos, yung distance ng ating cutting section mula dun sa pinaka-end is 0.5 of B. Yung uniform, yung stress daw dito ay hindi nako-concentrate or hindi uniform. Okay? So, ano nangyayari? Yung concentration daw ng ating force, it will look like this one. Okay. So, parang ganyan. Okay. So, parang mas concentrated doon sa pinakagitna. Okay. So, mentrans na lumalayo yung distance. Okay. Mentrans na lumalayo. Example, pinalayo ko pa ng kaunti. Ayan, layuan ko ng kaunti yung pinaka-cutting section ko. So, I have here the P. So, let's say this is around, according to Saint Venant, 1.5 of B. Medyo nagiging uniform na daw yung aking stress. Okay, so parang ganyan. Okay? Pero, kapag malayong-malayo na siya, okay, so assuming malayong-malayo na siya, okay, ayun dun, let's say yun. And then, that is around 2.5 of B. Okay? And then, meron ako dong force P. Doon na nagkakaroon ng uniform na stress. Okay? So, parang ganito. So, same like as this one. Uniform yung stress natin. Again, yung magnitude niyan, that is around P all over A. Okay? Force over the area. Ang tawag natin dito is actually the Saint Venant's principle. No? So, this is an actually loaded. Okay? So, sabi ni Saint Venant's, again, mentrans lumalayo ka dun sa end, okay, nagiging uniform. Okay? Pero dito sa static, sa deformable bodies na gagawin natin, okay, hindi na natin i-consider tong mga to. Okay? Kasi masyadong tedious, masyadong mahirap. Biruin mo, aalamin natin yung magnitude sa kada point na yun, ano? So, mahirap. Okay? So, ang ginagawa sa engineering deformable mechanics, okay, it's a simplified application. So, palagi lang tayong uniform. So, sabi sa deformable bodies, basta yung force nag-a-act dun sa pinaka-centroid, ang resulting stress niya is a uniform stress. Okay? So, that is for the actually loaded. Now, ano pa yung ibang klaseng mga stresses? So, sa ngayon, we will consider only the actually loaded. If you still remember on your statics, okay, I will draw a certain bar, for example, ayan, example, I will be having this one. Okay, di ba? Palagi yan, ito yung inyong local X, and then you will be having here your Y, no? Kaya nga, di ba, ang turo sa inyo ng inyong statics, okay, you have here X, and then you have, pinapahanap sa inyo, what is the moment of inertia about X, what is the moment of inertia about Y, etc. Okay, ito yung mga axis na yon palagi, no? So, you have here the X, and then you have here the Y. Dagdagan ko ng isang axis, no? So, you have here the Z axis. Okay, so meron kang tatlo. So, you have the X-axis, the Y-axis, and then the Z-axis. Ngayon, meron tayong dalawang klase ng force. So, we have what you call the direct force And then you have here also the moment. Okay, or yung twisting. Pagbali. Okay, pagbali, no? In short, layman's term, pagbali. Yung direct force natin, okay, yun yung pagtulak or paghila, no? So, sabihin na natin, I will call it, let's say, tatlong direction, Fx, Fy, and then Fz. And then you have here the Mx, My, and then you have the Mz. Okay, nasan yung Fx? So, susundan mo lang yung pinaka-axis mong tatlo. Okay? If I say Fx, that is the force parallel dito sa axis na to. Okay? So, it's either on this direction or on this direction. Basta ang tawag natin doon, you will call it as Fx. Okay? So, yung force. Kumbaga, yung cross-section area, okay? Assuming, ito yung cross-sectional area mo, okay? Ito yung x-axis, okay? Ito yung x-axis. Ayan, hindi ko makita yung video ko. Teka, baka mali. Hindi ko makita. Ayan. Ito yung x-axis mo. Ito yung y-axis mo. And then, ito yung z-axis mo. Okay? Tapos, ito yung tinutukoy kong cross-sectional area. Okay? Kumbaga, ito yon yung part ng beam. Okay? Iyan yung cross-sectional area mo, no? Yung pinaka sa iPhone natin. So, ulitin ko, this is the x. This is the y. And then, this is the z-axis. Okay? If I'm telling you Fx, that is the force parallel to the x, iyon yung force ko na paganto. Dun sa area. Okay? Kung papansinin nyo, if this is the area, yung force ko is parallel to the area. Okay? So, parallel to the area. So, parallel. Okay? So, later on, tatawagin natin tong, okay, shear. Okay? Shear ang tawag natin doon. How about the Fy? So, again, yung Fy ko naman, that is the force parallel to the y. So, it's either pataas or pababa. Again, siya naman yung force na pataas or siya yung force na pababa. And since yung y natin, yung force na y, pataas or pababa, is also parallel, okay? Fy. So, again, this is also a parallel. And then, this is considered a shear. Okay? So, you will consider also that as shearing force. Okay? And then lastly, meron ako ditong Fz. So, it's either pahila, okay? Kumbaga, hihilahin kong pa ganun, kasi Z eh. So, it's either pahilahin kong pa ganun, or itutulak ko, okay? Or itutulak ko on this way. So, ito, yung Fz natin, ito, ang tawag dito is perpendicular to the area. Okay, I hope nakita natin yung perpendicularity tsaka parallel dun sa area. So, ang una nating i-discuss, ano yung stress na napoproduce gamit tong perpendicular. Susunod, gamit tong dalawa, yung shear. Okay? Ano pa yung mga klaseng stresses na i-discuss natin soon. So, iyon yung tatlo. I-discuss din natin yung mga stresses na to. Okay? Paano naman yung MX? Okay. Now, yung MX natin, okay, mas madali kapag ruler, no? Ulitin ko. So, this is the X. This is the Y. And then, you have here the Z axis. Okay? So, we will always follow what you call the right thumb rule. Okay? So, si right thumb, if I'm telling you MX, you point the right thumb parallel to the axis. X, ito yung X ko, parallel. And then you open i-open mo tong pinaka right thumb mo, right hand mo, and then ibabaliin mong ganon. So, di ba? Naano niyo na yan sa mga physics nyo. So, babaliin mong ganon. It means, kung this is my x-axis, pag nabali yung member mo on this direction, okay, nakakapag-produce yun ng stress. Okay? So, ang tawag naman natin dun sa mga yon is flexural stress. I-discuss din natin tong klase na to. So again, meron tayong perpendicular, which is called the axial stress. Meron tayong parallel, we call these two as shear stress. Okay? And then we have here the flexural stress. Both, kasi MX pa ganito, okay, pa ganun, pababa. Yung MY naman lateral, no? So parang binabalik kasi Y pataas, so babalikin mo yung member on this direction. Okay, ang tawag natin doon is also a flexural. So, these two are called flexural stress. Okay? Pagdating sa MZ, okay, you point the right thumb on the Z direction and then you are going to twist the beam. Okay? Kasi pag ganito yung twisting eh. Okay? So, ang tawag natin sa MZ is actually this is called the torsional stress. Okay? So, meron tayong different types of stresses na pag-aaralan. So, we will have axial stress, we will have the shear stress, we will have the torsional stress, and we will have the flexural stress. Okay? So, all those stresses ang ating pag-aaralan. Okay? Sometimes, the axial stresses are called normal stresses. Okay? Sa statics nyo, di ba, na ano nyo na yung normal at saka yung parallel and normal stress. Okay? So, we will be having here called a normal stresses. Okay? So, again, we have different types of stresses. We have the axial stress, the normal stress, the shear stress, torsional stress, and lastly, the flexural stress. Okay, so ayan, medyo nakaka-stress ng konti na. So, iisa-isahin natin. Ang gusto ko lang maintindihan nyo kapag tinanong ko yung types of stresses, lahat yon with respect to the area muna, no? So, dapat alam natin yung area. Okay? So, I will give an example for this one. So, let's have this example. Okay. So, the bar ABCD consists of three cylindrical steel segments with different lengths and cross-sectional areas. Actual loads are applied as shown. Calculate the normal stress on each segment. Okay. So, yung tinutukoy nating segments, ito yung dami ng material or dami ng sections na magkakaiba. Example, yung buong section 1 na to, okay, lagyan natin ng point. I will have it point A. So, let's say this is the point A, point B, point C, and then point D. Okay? Yung segment from A to B is constant. Okay? May area daw siya na 1.2 inches squared. Kumbaga, in 3-dimensional, para siyang nakaganto eh. Okay? So, yan na natin. Yan. Para siyang nakaganyan. And then dun, meron din dun. Okay. So, parang ganyan daw yung inyong cross-section area, no? So, this is the point A, the point B, the point C, and then the point D. Okay? Tapos dito, parang tinutulak siya ng 7,000 pounds. And then dito, at this point, okay, itong palang mga 2,000 and 9,000 pounds na yan, okay, so, possible kasi sa kanya, okay, pwede, let's say, meron isang member na nakadikit, tinutulak siya, kaya nandito yung concentrated force, ano? Okay, so, hindi natin alam kung saan yan. Pero, dapat, for example, kayo, no, sa mga mechanical engineering, example, nagkaroon ako dito na another, tawag dito, another bar dyan, nilagyan mo ng bar. Tapos, hinihila ko to ng around, let's say, 1,000 pounds. And then, dito is another 1,000 pounds. Okay? So, kapag hinihila ko yun ng paganon, so, parang at this point, okay, hinihila ko rin doon ng around 2,000. Okay? So, parang yung resultant ng dalawa, which is 1,000 and 1,000, napupunta doon. So, this is resultant. Okay? Yun yung mga resultant. Okay? Yun yung mga possible kung bakit nagkakaroon ng mga loadings dun sa in-between the sections. Ano? So, maraming dahilan. Okay? Pwedeng dahil sa temperature, etc. Okay? So, ganun din dito, parang hinihila naman daw siya ng around 9,000. And then, dun is tinutulak siya ng around 4,000. Okay? So, yun yung 3-dimensional niya figure. Ano? So, again, dito, ano lang to sample lang. Sample only. Pero hindi ganyan talaga yung figure. Okay? Para lang ma-visualize natin kung saan nanggagaling yung mga forces na yon. Okay? So, ginawa natin 2-dimensional, una para madaling i-drawing at madaling i-analyze. Okay? So, yung number of segments is depende sa number of cross-sections area. Example, ayan, magkaiba siya ng cross-sectional area, yung A to B, B to C, and then C to D. Okay? So, kailangan malaman natin, iba-iba yung stress na nararamdaman ng kada segment. Kasi magkakaiba sila ng cross-sectional area. Okay? So, now, una, kailangan i-check nyo muna kung nasa equilibrium ba yung mga forces. Bilangin mo lahat ng forces ng pakanan. So, you have 9,000 and then 2,000. So, that's around 11,000 pounds. Lahat naman ng pakaliwa. So, you have 4,000 and then 7,000. So, that's around 11,000. Kapag equal silang dalawa, so ibig sabihin, this is solvable. Okay? Kapag hindi sila nag-equal, merong mali, no? It's either merong support dapat. Okay? So, dapat lagi silang nasa equilibrium. Okay? Para makuha natin yung tamang stresses. Since this one is in equilibrium, pwede na natin siyang i-analyze. Okay? Mamimili ka. Ano yung gusto kong unahin? Section 1, Section 2, or Section 3? Okay, unahin ko muna si Section 1, syempre, no? So, yung Section 1 natin, kinat ko siya in between A and then B. So, I will call it as segment. Ayan, may umiiyak ng ano. Segment AB. Okay? Si segment AB ko, pag kinat ko siya, kasi hahatiin mo ngayon sa dalawa, yung buong figure, pag kinat mo sa Section 1, hahatiin mo siya sa dalawa. Mamimili ka. Kanang side or kaliwang side ng figure. So, pwede parehas. It should be the same. Pero syempre, dapat pili ka na ng mas madali. Example, kinat ko sa Section 1. Ang dami kong idodrawing kapag pinili ko yung right side. Okay? So, ayoko mag-drawing, tamad ako. Yung left side na lang ang pipiliin ko. So, in short, ito na lang idodrawing ko. So, I will be having here this segment. Tapos, ito yung cutting plane natin. Okay, ito yung cutting plane mo na 1. Okay? So, ilalagay ko lahat ng forces. So, dito, meron ako ditong force na 4,000 pounds. Okay? Pinili ko yung kabilang side. Again, this is around 1.2 inches squared. Okay? Now, wala nang ibang forces dun sa left side ng cutting plane. Question is, in equilibrium ba yung 4,000? Again, ito is called an external force. Okay? So, hindi, no? Kasi kung yan lang yung figure mo, mag-move to the left yung pinaka-figure mo. So, kailangan may mag-resist sa kanya. Iyon yung ating internal force. So, for this one, kailangan kontra dito sa force na to. Yung force ko na to is pakaliwa. So, technically, yung isa is pakanan. Okay? So, ito yung ating internal force. Okay? Internal force. And tatawagin ko yung P, A, B. So, para alam ko that is the force on the section AB. Okay? So, meron tayong dalawang klase ng force, no? Kung ito yung cross-section area mo, tapos yung arrow na na-create ng internal force is away. Okay? Away. Okay, ang tawag natin sa kanya is tensile. Okay? And then kapag ang force mo naman is moving towards, 'di ba, dun sa statics nyo, kapag moving towards the plane, okay, ang tawag natin niya is compression or tinutulak. Oops. Or compressive. Tensile stress. And then you have here compressive stress. Okay? So, you will be having this one. So, ibig sabihin, at PAB, ang nararanasan niyang stress is actually a tensile stress dahil away to the cross-section area. Ilan nga yung value nito? Kung 4,000 to, napakadali kahit hindi nyo na-calculate. So, this is around 4,000 pounds. So, yung stress na nararanasan ng AB, and I will call that as sigma, that is a symbol for the stress. Okay, so you will be having here sigma AB, and the formula is the force on the AB all over the area of the cross-sectional AB. Okay? So, we have the force. Yung PAB natin is around 4,000 pounds all over. Okay? The area. So, ang area natin, sabi, it's 1.2 inches squared. So, that's around 4,000 divided by 1.2. So, you have here 3,333.33. Okay, that is pounds per square inch, or what you call it PSI. Okay, so you have here 3,333.33 pounds per square inch. So that is in PSI. Again, I will denote it as positive, no? Okay, basta wala naman, positive yun eh. Ibig sabihin lang kapag positive, this is a tensile stress. Okay? Next, punta ngayon sa segment B. Doon sa segment B, kung mapapansin nyo, dalawa na, no? Pwede kang, equal na equal eh. Sige, pili na lang tayo kung saang section, kung right or on the left. Piliin ko yung right side. So, it will be having this kind of figure. Example. Yan. And then, ito yung aking cutting plane. Okay? Again, piliin ko yung right. So, I have here 4,000 pounds. Tapos, lagyan ko ng name A, B. Okay? Dun sa point B, meron din ako dong force. So, that's around 9,000 pounds. Okay? So, pinili ko yung left side. Okay? Again, this area, which is area 2, meron tayong 1.8 inches squared. Okay? So, what we will do is to find, unahin muna natin, no? 9,000 sa kanan, 4,000 sa kabila. Para maging equilibrium, okay, summation tayo ng forces, sobrang na sobra sa kanan, no? So, ibig sabihin, ang kailangan ko is now a force na paganto. Okay? So, that is my force BC. Okay? So, dapat maging equilibrium. Kung 9,000 pounds pa kanan, meron akong 4,000 pounds pa kaliwa, I need more 5,000 pounds. Para 4,000 plus 5,000, 9,000, and then they will now be in equilibrium. Again, ito yung kailangan ko, yung PBC. The force on the cutting section or what you call the internal force. So, with this, pwede na ako ngayong mag-solve ng sigma, and that is on the member BC. And that is PBC all over the area of the BC. Ang PBC ko, it's just around 5,000 at ang area ko, it's around 1.8 inches squared. Okay? So, with this, I will now have the stress on the BC equal to 5,000 all over 1.8. So, that is around 2,777.78. Again, pounds per square inch. So, you will be having here your PSI. Okay? And I will denote it since, ayan, yung force ko is towards the cross-section, I will denote it as negative. Okay? Negative, it means compression. Yun lang ibig sabihin na. So, yung sign natin ng positive and negative, to denote lang natin if the normal force is in tension or in compression. Sa ngayon, hindi pa siya ganong mahalaga. Pero pag dumating kasi tayo doon sa ating strain, mahalaga na yung symbol, no? So, we will be having here tension. And on the BC, we have here the compression. Okay? Lastly, i-drawing natin yung segment BC. CD. Segment CD, ayoko nang i-consider yung yung left side kasi ang dami nang i-drawing. So, ang i-drawing ko naman is yung aking right side. Okay? So, again, ito naman yung aking cutting plane. Okay? So, now this is the point D. And then, meron ako ditong force, compressive force na 7,000 pounds. Okay? So, para maging equilibrium, kailangan may magkaroon ako ng force dito. And that is actually your force in CD. And that is equal also to 7,000 para maging equilibrium. Okay? So, pwede na ngayon ako makapag-have ng stress ng CD. And that is just equal to the force on the CD all over area of the CD. So, ang force natin internal, ito po yung kulay violet. So, we will be having here 7,000 pounds. All over the area, ito daw yung area natin. So, that's around 1.6 inches squared. So, you will be having here the segment CD is equal to 7,000 divided by 1.6. So, that is 4,375. Oops. Okay. Again, this is pound per square inch. So, you will be having here PSI. So, we will be having here on the segment AB, stresses, tension. Segment BC, compressive stress. And then again, we will be having here minus and to denote that this is a compressive stress. Okay? So, iyon yung ating tatlong stresses sa kada section. Okay? Ganun lang, napakadali lang naman ng normal stress, no? That's just P all over A. Okay?